Hello, everyone. Hello, everyone. Welcome to Awkward Devs number 127, 126. Couple things on the agenda today. As mentioned on the consensus layer call last time, we're going to spend some time talking about Kintsugi and the upgrades we had there. Then we have a couple EIPs and things about the merge to discuss. But first, just wanted to mention Aero Glacier. So the Aero Glacier upgrade is happening on December 8th. All of the clients have a release ready. I'll just share my screen real quick. There's a blog on blog.ethereum.org with all these releases. Otherwise, in the execution specs repo, there's also a link to the spec with all of the client releases associated with it. Yeah, so you can find them here. There's only a single thing in Aero Glacier, so just the difficulty bomb pushback and nothing else going in. So that was the first one. Next up, Kintsugi. So I'm curious, have any clients basically made progress on the specs? Any issues people want to bring up?
I can give you an update. So in Nethermind, we implemented EIPs, changes in execution engine API. Of course, we have to do more tests. We have to recheck our sync process, and we need to add message ordering. However, even without these changes, we are ready to start testing with consensus clients. What is more, we pass test with merge mock and test vectors. So yeah, that is update from Nethermind.
Nice. Anyone else?
Yeah, so from Geth, I created a version with EIP 4399 enabled. I'm not sure if we have to decide whether we want to run the first testnet or the testnet on Monday with 4399 enabled or disabled, because it changes the block hash. And yeah, so I have one version with 4399 enabled, but I can also create another one without it. And yeah, I created test vectors for, like, the test vectors are without 4399, but I can also create test vectors with 4399. And Mario created a really nice tool to run test vectors and to create easy test vectors for the execution layer. And yeah, currently it only runs with Geth, but we hope to extend it to other clients soon.
A couple things there. The weekly DevNet launches, which we'd like to kick into gear next week, will be on Thursday rather than on Monday. So there's still a little bit of time to coordinate between now and then. And I'd say if possible, it would be best to just do it full feature unless we have a particular reason not to. But I guess we should circle back on I'll have Perry put a proposal together so that on Monday, Tuesday, we can iron out the last details before Thursday.
Yeah, just to confirm, Nethermind, did you guys have 4399 implemented as well?
Yes.
Awesome.
Cool. And I asked y'all to update if you have done M1, which is just getting basic implementation and testing together. Mark it on the spreadsheet so that people can do a little bit of pairing at the beginning of next week.
There was also something raised by Merrick on the test vectors as a response for the update fork choice. If there's no execution payload, Geth is returning 0x for payload ID. Is that the behavior we're expecting or wanting? Because the spec seems to imply that it's null value or not, doesn't exist on the object.
Once again, what's the case when it should?
It should be
What's
no,
passed on to the fork choice updated?
if there's no execution payload, there's no payload ID. And so I understood it should be null.
Okay. Yeah.
Yeah. Oh, it's just an error in my code. I can fix it.
Okay.
I'm also wondering what should CL send when the fork choice updated when it literally creates the first, initiate the build process for the first payload in the network. So what should be the fork choice state that passed on this call?
I see.
Yeah, because there is no yet payload that is the head.
Right. I mean, semantically, setting the head as a proof of work block might be, as the proof of work block you're building on might be the correct thing.
Yes. So
Yeah,
that's what we currently need. We need
Yeah, I think.
Okay.
we need the consensus layer to send us the head that they want to build on.
Yeah, which makes sense. I mean, if you had two viable competing terminal proof of work blocks, the consensus layer needs to pick one to build on, and so that I think should be the way we do it.
Yeah, right. It sounds correct, but just was wondering because this is something
Underspecified.
probably. Yeah, right. It's just, it means that with this call, the fork choice rule will be switched to the proof of stake fork choice rule as well.
Right. Which, again, I think makes sense.
Yep, I agree.
Cool. Anyone from Aragon or Besu have updates?
Yes, so we have a team member, Julio, who has started working on the merge in Aragon, but it's still very much at the beginning. But I believe Julio is on the call, so he might give us an update if he likes.
Oh, yes.
Okay, regarding AP 4399, I started looking at it yesterday, so I'm still like trying to understand how we can implement it into Aragon, but yeah, nothing new for now since the last call.
Cool. So yeah, and you're still basically implementing the EIP 3675 as well, I guess, the actual merge EIP.
Yeah.
Right.
Great. Cool. Anyone from Besu? Is there? I don't think we have anyone from Besu on the call.
Yeah, I can talk.
Oh, Fabio,
about
yes.
this.
Sorry, I'm trying to
Yeah.
scam the grid.
No problem.
Awesome.
Yeah, about this, Gary is mainly working on this, and I can't add too much. Looking at the issue, don't seem to be a lot of progress lately. So, but Gary can for sure tell more, but it's not online at the moment. So.
Okay, no worries. Was there anything else aside from like the client updates and the issues we've touched on that people wanted to discuss about Kintsugi?
Yeah, I have a quick point about the 3675 spec, which was slightly different than Amphora. And I just want to highlight that. If you take a look at fork choice rule in 3675, if you look at the first note in italicized, says the proof of stake POS fork choice update event must be respected even when the transition block of the fork choice is not a terminal proof of work block from the view of terminal total difficulty. They're essentially in the consensus layer. The consensus layer and execution layer will both be shipped with terminal total difficulty. But in the consensus layer, there is a potential manual override, which can only accelerate the merge, so make a lower terminal total difficulty or set a hard-coded terminal block hash. And because of that, and to avoid complexity of having to do this override in 2 places, and some of the errors that might occur there, it's only on consensus layer. And so the consensus layer might have a view where terminal total difficulty might be earlier than what the EL has hard coded. And so the EL must listen to these fork choice updated events, even in the event that it seems a bit early compared to the terminal total difficulty. So there's no need on the fork choice rule to validate TTD, but EL still uses local TTD to turn off block gossip and block import for the P2P. And the second thing I linked is a deeper discussion of that design consideration. And I just wanted to, there was some testing and some different failures and different logic changes around the validation of TTD in EL. So I just wanted to point that out, that the spec says slightly otherwise than what it did in Amphora. Question? Okay. If you have any questions around this logic change, just ping me.
Cool. Any other issues related to Kintsugi that someone wants to bring up?
I want to bring up a small issue.
Sure.
I just dropped in the chat. This is the issue to discuss the validation error format, which will be used by EL to send the validation error that happens during the execution of a block or validating the block header. This is mostly, so initial thought was, this is mostly like for UX purposes. So the CL client will be able to just log some message if the payload is invalid, and it can read from the logs and without the need to go to the EL client log and match the payload hash and what happened, to investigate what has happened. So it would be great just, to see more opinions before making the final decision how it should be done. For more EL client developers. So that's it.
Okay, thanks for sharing. Anyone else? Okay, if not, I think, Mikael, it's also worth it to go over your related point about the fork identifiers for the merge before we dive into the 2 EIPs we wanted to chat about.
Yeah, cool. So we have, so we have to specify fork next and fork hash for the merge EIP for in 3675. And from what we have discussed during Amphora drop, these numbers and these primitives should not be affected by the merge. So literally fork next just stays 0, and fork hash is the same as of the previous fork. But when it's turned into the spec change, the question of how it should properly be implemented appeared again. So I just wanted to just want to discuss this and make a final decision and make the respective change to the EIP. And my main question here is, if we have the fork hash, just suppose the merge has happened and the fork hash hasn't been changed, and suppose the proof of work network keeps progressing, and considering the fact that the sync process and the fork choice rule and everything else will be coming from the CL side to EL, and also considering that block gossip will be disabled, what can go wrong in the worst case if the fork hash of the nodes that run in the proof of stake network will be the same as of the nodes that are running in the proof of work network that keeps progressing. So that's the main question. If my gut is that nothing bad can happen. They will these nodes may exchange with transaction messages, but I don't think it's a problem. So yeah, we need to decide because we can't update for cache easily, like retroactively or like with how it currently specified in the EIP is that the fork hash is going to be updated when the real transition block number is known. But if it's done, it could like split the network because nodes that are in sync and not yet know this transition block number, their fork hash will still be the old one, but the nodes that has passed the transition will have a new fork hash, and they just can't talk to each other. That's the core. That's the problem.
Right.
So someone. Go ahead, Danny.
I was just going to say, is this helps filter peers when things are well specified and known in advance, and if we don't utilize this mechanism for this upgrade because it is hard to get right and can cause this splitting because of the dynamic nature of the fork block, if I understand correctly, it would only reduce our ability to filter our peers, but if we have stable connections and peers, we'd probably be in good shape anyway. Is maybe avoiding this mechanism here a potential path so that we don't have to worry about the issues?
Am I correct in understanding that someone who just continues running proof of work and does not switch over to proof of stake, the only network that they're still gossiping on is the transaction network? Is that correct? Like they otherwise don't share any connections. Is that accurate?
Yes. Yeah, but other methods will still work, like blocks and no data or snap sync stuff.
Right. So there's more direct requests rather than gossip. That's still very good.
Won't, as soon as the first block comes in, you get like your execution layer node will say, hey, I'm not expecting any more blocks. You're bad. I'm disconnecting you. I guess the first block after first finality, I think it's more accurate. Is that correct?
If somebody's gossiping proof of work blocks beyond.
Right.
Yeah. So like
that's in the spec
the network
already.
Right. So the network should split after the first finality. Is that correct? Like everybody should disconnect from each other basically, and they'll stop trying to talk to each other. And so we should get a nice clean partition at finality, at first finality. Is that an accurate statement?
I'd say yes. That's a good point.
And so if that's true, the duration of this problem is for the time from the fork to first finality. I heard a groan from what I think was Martin.
It was from me, Martin. I think if we have, if all that happens is that one side disconnects the other, that's not a clean disconnect split. It just means that the disconnected party will try again and succeed to connect, and then eventually get kicked out again, and it will continue that way. If we want something clean, think we should think about how this type of how we could integrate this with fork ID somehow. And I know there's been a discussion about that. Fork ID is usually based on numbers, and after the fork, we do know the number, so we could, I don't know if we like retroactively could modify the fork ID in hindsight, but during runtime, as in not like putting out a new client, but the client dynamically modifying.
Yeah, right. But according to the EIP, don't remember the number.
That way we could achieve a cleaner step.
Right, but
Mikhail, what if you do it at?
Sorry. Any?
What if you do it at finality instead of once the transition block is known?
So when we do the fork ID transition?
I'm worried that according to the spec, the node that has just started to sync with the network, and will try to connect to those that has that just passed the transition, even they reach the finality, and whenever the fork hash has changed, it will be different. And according to the current spec, it should just not connect to this node because it doesn't know. It's not. This is a known fork hash for the node, for the local node that connects to the remote one, and it just drops the connection. That's my understanding of the spec. I mean, of this EIP that introduces fork identifiers.
I'm not sure I fully heard what you said, but yeah, I mean, we can achieve a clean step if we use the fork ID. I agree.
Yes, but if you set it retroactively and during runtime, so you can only do this when you know the exact number, right? But if you this number is not known for the local node because it's still syncing and hasn't reached this block, it will use different fork hash, and it will need to connect to someone to give to pull the chain data and get synced, but it can't connect because the fork hash is different.
Yes. So
is that strictly true though, that you can't connect if your fork hash is different? Because the way fork connects, I need to dig a little bit deeper into CMP, but I believe the way the fork connects is that if your peer doesn't know about a fork, that you can still connect to in a certain capacity, and you wouldn't totally disconnect from them because they may be syncing.
If you can recreate the fork, if you can get the same fork hash using the fork next and the upcoming fork hashes, then you can connect. If you can't do this, you should disconnect, or you must disconnect according to the spec. This is my understanding. Probably it's wrong, but I've read it for several times.
No, I think it reads that way. I think the thinking is that this would have been a fork that happened in your past, and according to your past, it's not something that you respect, so then you ignore it.
Is the expectation with fork IDs that all of them are known at startup? So when you boot a client, you know all fork IDs that your clients should be able to sync with, up to and including the latest.
I think so.
And the issue here, if I understand correctly, is that because this fork doesn't have a known, the fork IDs currently are based on block number or hash?
Block number.
Okay, so the issue here is normally for every other fork, we know the exact block number from Genesis block. If you just start up a client brand new and you have Genesis and a config file, you already know the block number for every future fork that up to the date you download the client. And so therefore you should be able to connect to anybody because you all agree on the fork numbers. The issue here is that we have a fork that we can't hard code the block number in, at least until the client release after the fork happens. And so we're in this weird situation where you don't actually know that from Genesis, and therefore when you connect, you don't actually know what block number to say that, hey, I'm expecting this for the fork ID. Is that all accurate?
Actually, you can't even hard code it after the fork.
because if you hard code after the fork, and for example, I restart my client and I say that, okay, I did a fork 10 blocks ago, then everybody else will drop me from the network because they will see that I'm at block 20 million. I did a fork 1 million block ago, but they are again similarly on block 20 million, but they did not do a fork 1 million block ago. So essentially, them and I'm on two separate forks based on the fork ID rules.
So we could create a synthetic fork block number where essentially it's like everyone should upgrade their EL client to be proof of stake capable by this number. And this is also the number that it would be using for fork hash, and then TTD would be sometime after that.
Yeah, that way we get the nice clean separation of networks, which will basically be people who upgraded to proof of stake and people who didn't, or rather, people who upgraded their execution clients to a proof of stake capable execution client, and those who didn't. And once that block number, which is a fork block with essentially no code changes in it, once that's reached, the network should partition cleanly, and then when we get into TTD, we don't need to worry about fork ID. Is that line with what you were trying to describe, Danny?
Yes.
I have a question. This fork identifier, it's also used in the in discovery, right?
Yes.
Okay. Yeah, we can pick like large block number that will definitely happen after TTD as well.
I think for Danny's idea, I think we'd want to target before TTD.
Yeah, that was nice.
And I do think there's maybe value in that because it kind of gets people downloading both clients. Like anyways, there's going to be a change to the consensus layer before we hit TTD. So we can tell people to also upgrade their execution layer clients at that time. And then they're going to have to upgrade their execution clients once more as we get closer, I guess.
And what's the purpose of setting it before TTD? Because
so that way,
if somebody
will
run the proof of work network after the merge, so it will also include this number as well.
No, so if you upgrade your execution clients to the client that has the code that says there's a new fork, empty fork at this block, then we know that your execution client, assuming you didn't hack it or whatever, will turn itself off when TTD is reached. And so we're confident that you will at least not continue on a proof of work network. Like you will, you'll just stop at TTD, worst case scenario, if you don't run
There's
SCL.
something a bit funny here with miners, essentially. If they intend to not do the fork, then we will disconnect from them at this point.
Oh, yuck.
Right, but they still have, that's not actually true though, because they still have an incentive to mine all the way up to the very last block, like they get paid. So they're if they disconnect then, it basically says, you know, like we're losing this amount of hash rate. And that might actually be a useful data point, knowing like X% of the hash rate is not even going to bother mining close to the merge. Yeah.
So that is true, but so like already there's kind of incentive for miners to leave early because sell your hardware off beforehand. This is just one more incentive. Like we're basically saying you have to do this last upgrade, or if you want to stop a week early, you know, you don't even have to bother upgrading your infrastructure. Or it'd be nice if we can just say, hey, miners don't even have to touch their infrastructure. Just keep running your old clients right up until the last minute. You don't need to do anything. And that way we retain as much as possible so we don't have a precipitous drop in hashing power at the last minute. Now, I don't know how strong that incentive is. I don't know how difficult, you know, upgrading client software is for miners. And, you know, supposedly there's some mining pools that are going to be switching to proof of stake, and so they'll probably upgrade anyway. So maybe it's not a big deal, but it is an incentive.
So I think in practice, assuming they want to keep making money, you know, some of the miners, as you said, are mining pools. A lot of them will also use something like flashbots or whatnot. And like, if they want to keep, you know, basically making money on MEV as well, they need to upgrade. So I don't. It feels like if they're going to drop, you know, if for them the calculus is like I want to drop before the merge, yeah, they're probably going to drop anyway. Martin.
Yeah, I was so I understood one of the drawbacks of having a dynamic fork ID thing is that it makes it difficult for nodes that are in the middle of syncing or are wanting to do a sync right around when T3 hits. But I didn't really understand, Peter, what you said about it being impossible or being the problems that you saw with it. Dynamically switching to another fork ID.
So the problem is if the entire network simultaneously switches to swaps in a new fork ID, that's fine. But if part of the network swaps in a new fork ID and the other part does not, for example, because it requires a new client or requires a restart, then what happens is that the clients who swapped in the new fork ID, they will suddenly advertise a fork in the past that the other clients are not aware of, which means that chain-wise, they are incompatible, they will disconnect.
Yes, and that's exactly what we want to achieve.
How will they sync then?
My example was when you wait on, so as far as I'm sorry, maybe I misunderstood it. I thought that this particular suggestion was that we wait until POS arrives, and then we just retrospectively say that, oh, by the way, yesterday's block was the POS block.
Yeah, well, we reached the total terminal difficulty block, and when we see it, we switch fork ID.
If we do it automatically, then the entire network does it, then it's fine.
That's the idea, yes.
Yeah, but then the entire network needs to do it.
But what if there are two blocks on the total terminal difficulty?
Yeah, it's
I think
probably safer to do it at finality if you do it.
Yeah, the only way to do it is with a finality block.
Yeah. Okay. Yeah, but so the idea would be that the entire network that does continue on proof of stake does so at basically the same time.
Yeah, but we can't actually do anything at the same time, though, right?
No.
Like within. Like one may see finality before someone else, and then they see finality, they advertise to someone else who has not yet seen finality. And then that advertisement results in them saying, oh, you guys, we disagree on fork ID, disconnect each other.
There's no disconnection happening on fork ID updates. So the fork ID is only verified when you do an initial connection, or in the ENS when you figure out whether you want to connect or don't want to connect. So current existing connections will not blow up because the fork ID changes. Just if you want to establish a new connection, then that might be rejected. But I think
if you're in the middle of,
yes.
Sorry, go ahead. So if you're in the middle of syncing and you're, let's say, almost caught up, you're like a day behind or something, or an hour behind head, almost caught up with syncing, and then you shut down for a reason, restart your computer or power outage, whatever, and you come back up, you won't be able to connect because you don't think that, because you're past the fork block. And so you try to connect to people and they all say, hey, the fork block was, back there, that block you downloaded, and you say, I'm past that block, that was not the fork block because you have not yet reached TTD. Is that the issue?
But that cannot really happen because for you to reach that point, you would have to have a consensus layer client already running. And the consensus layer client would then feed you the current head, and you could sync up to that head.
Okay, once again, everybody has transitioned and switched their fork identifiers in the network. I'm like the new one, the new guy. I'm just starting my node, let's say half of an hour after the transition has happened. I'm trying to join, my execution layer tries to connect to everyone that has the new fork identifiers, but I don't have it locally because I don't know that I don't even know that I should change something, in my AL client to be able to connect to the rest of the network. My question is, in this case, how would this client that doesn't know about the fork ID has updated? How would this client be able to sync with the network?
In that case, there's actually a chance that so yeah, I know that in one direction it is permitted, so you will connect as long as you consider that you have enough data to download. I'm unsure what happens I think it will allow connections because from one side, the peer that you join to, they will see that you're advertising the next block will be Homestead for you. So they will say that, okay, Homestead is at block 1,700,000 something. You think that that is the next fork, you're outdated, you are just wanting to sync. So the peer that you join to will allow you to join because they don't know that you're on some other fork. The only information they have is that you're at Genesis and the next fork is Homestead, it matches up, you want to connect. So from that perspective, the connection will be allowed. From the other perspective, what you will see is that the other person is actually on a fork ID that you know nothing about. And that might actually cause you to disconnect because the other side will actually advertise a fork ID, this hash checksum that you cannot compute because you're missing the thing. So actually, I think you will refuse to connect to anybody who's already on POS. So in that case, possibly there would need to be a upgrade, a client release with the hard coded thing. Otherwise, you wouldn't be able to join.
Yeah, that's my understanding too. Also, I don't think that if we set this fork next before the actual transition, it would differ much from if it were just 0. Because if somebody wants to keep mining and continue the proof of work network, they will just take this client release with this fork next and remove the TTD and other stuff, and do other stuff that needs to keep supporting the proof of work network, and just use this client, and the same fork next will be there. So as if you're just 0. So I think it should be after the transition has happened if we want to split these two networks.
Honestly, I think it doesn't really matter whether it's a little bit before the transition, a little bit after the transition. Generally, the reason why we introduced fork IDs was that, especially on the testnets, we had generally maybe 10% of the nodes upgraded to a new fork, 90% didn't, and then it was for the rest of the 90%, it took 3 months to upgrade. So during these 3 months, it was really annoying to find peers because you were constantly finding peers that were stuck on whatever old block or old chain. And we needed a way to somehow separate the two networks. So obviously, previously we did it very, very precisely because we precisely knew, but there isn't, I don't think it's necessarily essential for this fork ID to be extremely precise. So if we can just update the fork ID, I mean hard code the fork ID to an approximate block where POS will happen, then essentially that block will be the one that will split clients that upgraded versus clients that did not upgrade. And this is not really a protection mechanism against malicious people. So if somebody is malicious and they want to download the code and they download the get source code and rebuild it with modified, or they try to convince a lot of people to run malicious modified code, we cannot do anything. They could as well fake the fork ID. So fork ID is kind of like to prevent naive, non-upgraded users from causing too much annoyance. And from that perspective, I think it doesn't matter whether the fork ID gets updated 1,000 blocks or 5,000 blocks before POS or 5,000 blocks after POS. It's just the idea is that it shouldn't cause havoc for 3 months straight after the POS switch. I mean, yeah, of course, it's definitely better the more precise it is, but I don't really see any particular downside if it is not that precise. If there are a couple days plus or minus, in my view, it should still be safe.
Quick question: what speaks against just updating it well ahead? I don't know all the details on the peer-to-peer network, but here's one reason why that could be good. Basically, people who forgot to update their clients would then see a gradual degradation and thus get a very strong signal that they did something wrong and potentially be nudged into updating it in time. And so you'd have fewer people who, for some reason, weren't ready for the upgrade.
Yeah, my primary argument against that is that if a contingent of miners want to run the chain beyond the proof of stake upgrade and intend to do so, then they wouldn't upgrade their software to proof of stake software mode. And thus you might create a partition between those that want to upgrade to proof of stake and those that do not prior to the merge. And if a significant portion of mining power is that, then we might have delays in the merge because of dropping TTD and things.
Does this fork ID change the consensus part at all, though? Or is it only a networking thing?
No, it's networking.
Right. Because, do we actually know, because miners might not actually just use the normal peer-to-peer network even. They might use specialist servers that, guarantee them fast diffusion of blocks and stuff like that. They might get their blocks from block builders, flashbots, whatever. So, I'm not sure if we need to worry too much if they are still connected to the same peer-to-peer network. It's very easy for them to be connected to two peer-to-peer networks.
I mean, they certainly insert blocks into the gossip network. And
right, they do at some point, but
I don't know if we should assume that they don't use traditional means that would be locked out if they didn't do it.
I mean, I'm personally much more worried about people being exposed because they forgot to upgrade their nodes.
I think I'd also have, with Dankred here, I think I have a weak preference that I'd rather find out sooner rather than later that there's a contingent of miners that plan on continuing to run proof of work.
I honestly don't think you will find that. I don't think you'll get that signal.
Sure. We might not, in which case this is not a problem.
There's no need to do that, as a miner, my incentive is to definitely stay connected to the peer-to-peer network that's going to switch. So I'll do that somehow, even if that means running two nodes. So I don't think you get that signal that people will not distribute their blocks on our peer-to-peer network anymore.
Which would be great. I'm just saying, if Danny's theory proves out, I'd rather know, a month in advance instead of a day in advance of the fork. I'd rather not see the TTD drop off, in the last minute. I'd rather see the TTD drop off, a month ahead. So that way, when we set the TTD, we can set it appropriate to the actual hash power that's going to stick around to the end.
And this isn't necessarily my theory. I mean, the synthetic fork before was my idea, and I kind of like it. That is the primary risk, is that we accidentally fragment the miners off the network because they do not intend to upgrade to proof of stake. But I don't know if I wouldn't say that that's necessarily what I think is the likely outcome, but I think that is the primary.
I mean, if that is a risk that we see, then we can also easily add a command line flag that says, yes, follow this new proof of stake fork ID, but do not switch to proof of stake. An override flag for that. And then miners can easily just do that and don't have to worry about modifying the clients themselves for that.
Which is another risk in and of itself. make contentious work dash dash.
Question.
But do we really think do we really think we can stop that fork existing?
So
like I doubt it. So I'm not worried about adding that. I just want it to never be the default option. Like the default option should always be, if you just do the normal thing, upgrade your client, you should end up on proof of stake. And you should never on that path, you should never just end up on a proof of work fork and everything seems to be working and you then notice that's like you forked off.
So it seems like we have a couple options on the table. There might be value in kind of thinking through them a bit more explicitly off the call. Like, I don't know if we need to make a decision about this right now. I don't think we do.
Does anyone currently have strong opinions on this, or is everybody kind of meh on all the proposed solutions? I know personally I'm meh on all the solutions. I have a minor preference for just a fake empty fork block ahead of time, but I'm not going to die on that hill at all.
That's my weak preference.
Question. What do we want this whole for? So essentially, what is the problem that we're trying to solve here? Because the fork ID, originally the idea behind the fork ID was that we needed to separate an upgraded versus non-upgraded networks apart after the upgrade happened. Now, if this is the goal, we actually have an interesting other thing that we can abuse for this purpose. Specifically, that as far as I understand it, correct me if I'm wrong, after POS mode, the total difficulty of the chain essentially remains constant. So there's no more blocks don't have a difficulty anymore, right?
Yes.
Okay, so in that case, if for existing nodes, once POS happens, and let's say finality also happens, so that's fork plus, I don't know, 15 minutes or something like that. Essentially, after that point, when I'm in fully in POS mode, whenever an ETH handshake happens, I can actually just both sides advertise their total difficulty to one another. Now, if somebody advertises a total difficulty that is higher than my TTD, or not, sorry, not the TTD, rather the higher than the total difficulty of my last block, the POS block, from which point the whole thing is locked in, then I can just disconnect it. So with this trick, essentially POS aware clients can always disconnect non-upgraded clients if there's actually at least one more block mined on top of the TTD.
Yeah, that's interesting. But as you have mentioned, as you have pointed out, that this is more important for like to force as an indicator of as an indicator and a signal for a user that it just forgot to update its client software. So I mean this fork ID. So it will after the client release. Yeah, so it's not gonna disconnect, or will it disconnect the nodes that has different fork next, or just set to 0? Like my client is updated and somebody tries to connect to me and has the fork next set to 0, but my client has the fork next set to correct value. I think it's permitted, right?
I think in that case, you will be the one, your client will be the one disconnecting it once it goes past the.
Oh, yeah.
Oh, no, wait, actually, if there's only the fork next is different,
Yeah.
then clients don't disconnect, because then it just means that one of them might not be up to date, but as long as that fork didn't happen, it's fine. But once that fork happens on the updated side, then the fork next will be 0 at that side, and just the fork hash will be different, and that will
Yes.
trigger it.
Right. So if we want this for this kind of purpose, then we should set it before transition, before next to be before transition, and I think it's reasonable. If it's not like, you know, there is no security implications in that. Also, I think I know what to do with respect to the spec. So we can just have another constant that will say that the spec will say that fork next should be set to this constant and decide on the constant later on. So what it will be. That's the right, I guess, approach in terms of the spec.
Regarding your suggestion a second ago, Peter, do the clients already share their view of total difficulty, like during the connection handshake?
Yes.
Is that information we already have? Okay, so we already have the messaging and everything. This would just be adding a line to the client that says disconnect if total difficulty reported is higher than the TTD that I think should exist, right?
Yes. The only thing is, I'm not sure that will probably not help us for a client that is just joining, and maybe that's the hard part that we actually want to solve. But
I'd say if we use the, sorry.
I just wanted to say that, but I still kind of feel that if we set a fork block that is before POS, I mean, we just set the fork ID 10,000 blocks or a week before TTD is supposed to happen, and we just have a couple nodes on the network that just relay blocks between the two networks. So you could just somehow have a node that. So essentially, if I understand correctly, the thing that we're afraid of is that if there's during or right before the fork, there's a set of miners which don't want to upgrade, we still want to consume their POW blocks. And I think we could do that by simply having some peers on the network that, quote, connect to both networks and just replay the blocks across them.
That sounds like a lot of engineering effort.
I'm not sure that it's my hunch is that you somehow get away with it without. I don't know. It's
yeah, run two nodes and use local RPCs to drop blocks between each other. But you wouldn't put it into the gossip from there. Anyway.
No, I was actually figuring. I was just wondering if I can create a node that can, depending on who it connects to, just can advertise different fork IDs. Essentially, just lie about the fork ID and just lie itself onto both networks.
What's your fork ID? I don't know. What's your fork ID?
Why are you asking?
Actually, no. Actually, that's good. No, that was perfect. That is the solution. So the handshakes are transmitted concurrently. So it is perfectly fine to wait for the remote handshake before sending yours. Of course, if two of these lying nodes connect to each other, that's going to be interesting. What's yours? What's yours? But otherwise.
Yeah, Peter, to your point, we can use hard-coded TTD to disconnect peers. So it will be hard-coded and everyone will know it, even if Node just starts to see
yeah, but the problem is that you don't know what you just know the TTD, the terminal difficulty, but you don't know what the actual live total difficulty will be, the final one. Because you know that it's going to exceed TTD, but you don't know by how much. And that's the problem. That
yeah, I see what you mean. Yeah, I get it. Yeah, right.
I mean, I guess no, actually, if you're a fresh joiner, then you don't. Anyway, I think we shouldn't really hold up the whole discussion.
If you're a fresh joiner, wouldn't you have the weak subjectivity point? And so you would know what the TTD was? or does that not kick in until later?
And a fresh joiner could mean I'm running my node from a week ago and the transition happened 2 days ago. So I still don't have information about what happened.
Okay.
So I guess most of this complexity is just right during the transition or right after the next few days or few weeks, because after that, it's kind of probably the whole thing is going to stabilize and most of these mechanisms will get thrown out anyway.
Yeah, I prefer to have it before transition. So that's a good indicator for a user to, and yeah, like the good fact, it's one of the factors that they should update the nodes.
Exactly. So what we could do is, if we take that route and we're afraid of some blocks not propagating, then the simplest solution is to just hack in this this lying node that can just join both networks just to transmit the blocks through, and then just have that running for 3 days until the transition happens, and then you can just nuke it off when US happens. It's a bit of a dirty hack, but it keeps the code cleanest. The production final code that needs to stay in place.
Right. So I don't, is it worth, we've already kind of been discussing this for half an hour. Is it worth maybe continuing async and bringing this back up again on the next call? It's not something we need to implement for Kintsugi. Yeah, I don't know, unless people have a strong opinion about something, but it does feel like there's a bunch of weak opinions and there might be value in just kind of thinking through them a bit more.
Yeah, I think essentially here we need a few people who just be willing to just explore their own preference and then just see what it actually takes, how messy it gets, and if it works or doesn't work. Because we have a few ideas, but every idea has some catches, and yeah.
Yeah. Does anyone on the call want to volunteer to look into that in the next couple of weeks?
I can take a look at what it would take to make the malicious node. That's always fun.
Sure. Cool. And yeah, I guess Mikael, Danny, and I can chat about the next steps for like the other approaches and yeah, see how we can kind of flesh those out a bit more.
So I think from a technical side, the faux fork block should be absolutely trivial. Like it literally, we just introduce a fork that has 0 code changes in it.
Yes.
And so every client has a mechanism for introducing forks. This is just another fork, just like every other. It just, there just happens to be no code associated with it.
Cool. Yeah, just to be mindful of time, unless anyone has any like urgent comment about this, I think we should just move on because we have 2 more EAPs we wanted to discuss. Okay. So next up, Ansgar and Barnaby are here to give an update on EIP 4396, which is the one that proposed to change how EIP 1559 works in a post-merge context. Yeah, Ansgar, Barnaby, do you want to give a quick update of kind of what you've looked at over the past couple weeks?
Yeah, I can maybe start with a summary of the breakout session from last Monday. So basically, splitting up the EIP into 2 parts, like the why might we need to do something, and then what exactly to do kind of sides of things. I think the main result from Monday was that there's generally uncertainty around how urgently we need to do something. So basically, like, is there something that can wait until Shanghai, or is it something we should do at the point of the merge? There was also some talk on the mechanism side, but then Barnaby and I kind of spent some more time since then kind of looking into the mechanisms, and I think that's really solid. So the question is really more, is there need to do something basically. And just to recap that briefly, so like there's one small concern in general about just like that empty slots have a negative, like have a distorting effect on the base fee, where there's this brief base fee spike usually after a missed slot. But the main concern is about the throughput loss. So every time after the merge, there's a missed slot. Basically, the overall throughput of the network is just reduced by whatever, like by the 15 million or whatever the target would be in an average block in that slot, which just didn't happen. These kind of throughput reductions can be compensated in the medium term through gas limit adjustments. So if we see that, say, 3% of validators are offline permanently, we can just increase the gas limit by 3%, and then on average it smoothes out. There were concerns around specifically how well will we be able to adjust the gas limit after the merge. So right now, so of course that's the role of the block builder. So right now the miners, and then after the merge, the validators. It's already not trivial to coordinate miners around changes. Every time there's like a gas limit change, it takes a while, and then of course after the merge, validators are even more decentralized, so there's more people we'd have to reach out to before we get to 51% of people signaling a different gas limit. One thing that could help there actually is the centralization that's probably going to be introduced by the Flashbots proposed merge architecture, which, by the way, I think should be a topic for one of these OCODEVs as well, because that might introduce some general centralization concerns. But in this case, it acts to our advantage, because it means that we basically only have to reach out to Flashbots to adjust the gas limit. And then, yeah, and so basically that all helps for medium-term adjustments, but the issue remains for short-term adjustment. And that's really basically the question really is like, how important are these short-term adjustments, and do we have to do something about it in the merge? And so again, the facets there are like, for one, there's the concern around DOS vulnerabilities, and this is important. This is kind of not what we used to talk about in the DOS context, like say slow blocks, where basically transactions kind of like take very long to compute. This is the different form of DOS. This is kind of like identifying the real identities, the IP addresses behind this individual validator, and then targeting them and bringing them offline right before they were producing a block. And there's more incentive to do that if there is a if that basically results in a throughput loss to the network, so you can actually attack the network through that. Whereas if the throughput is compensated for, then of course you don't have much of an immediate incentive anymore. So that could be a mitigation against these DOS attacks. And then also there are other situations, though, say like a big staker goes offline for a couple of hours for some maintenance reason or something, that just could be like a 10% throughput loss for a couple of hours of the network, which is not great. Or in the scenario of like a client bug or a consensus issue or something, there could be they could basically say we have two forks and both have 50% of validators, then at least until the gas limit starts moving, which again could take like a day or more. But like the forks would only have half the throughput. Yeah, so that was mainly on the necessity side. So there's a lot also to report on the mechanism side, but it's more like detail oriented. And so I probably first want to just stop here and get feedback on like, do we need to do something? And then if people generally think that we want to do something, then it's probably, then we can, and then also Barnaby maybe can talk a little bit about the mechanisms. But yeah, so what are people's thoughts on like, is this something that is bad enough? So kind of these throughput losses and the DOS incentives and everything, is that something that is bad enough to do something about it now? And that was just basically on Monday, our conclusion was basically like, yeah, hard to tell, kind of like on the fence. And then of course, yeah, mechanisms I'm real optimistic about, but yeah.
Yeah, I see Danny has.
Yeah, I mean, yeah, a few weeks ago I was naively optimistic that we could shove this in here. test it quickly, and there wasn't much complexity to deal with. I personally think that this would likely delay the merge on the order of a minimum of a month, if not 2, just because of where we're at in engineering cycle and attempting to have specs frozen. Although I do think this is the good and arguably correct behavior, I do not think it's critical to have at the merge, and that personally, I think if we're sorting things, merge sooner is better than getting this in. But I would be a strong advocate for putting it in Shanghai. There are obviously various concerns as you enumerated, but I think between having the gas limit as a lever, even though it's still a lever, we can mitigate that most of the concerns there.
I guess does anyone see an issue with potentially raising the gas limit to offset kind of the average throughput loss? And I think like right now, missed slots are like less than 1%, if I recall correctly. So we should expect them to be in that like single-digit percent range. So that solves kind of the general case issue. The issue where it doesn't solve is if a large subset of validators goes offline for a while, then we have like a throughput reduction in the chain. Yeah.
I'm against raising the gas limit for any reason, just because I think the gas limit is already too high. So unrelated to this conversation, I'm not a fan of any increases.
Wait, but there, just want to briefly interject there because, I mean, like, at the end of the day, the gas limit is just a number, right? Like what you're probably concerned about is just the general throughput per time, and that wouldn't change, right?
State growth.
Yes,
state growth is what I care. So like,
sure.
Yeah, so if I see an opportunity to lobby for reducing state growth, I will take it. And so if there's an active discussion for should we increase the block, should we maintain the block throughput, or should we decrease the block throughput, I will vote to decrease it, which is basically what I'm saying here. Again, though, I recognize it's not related, just question was asked, would anyone be against it? And yes, I'm against it, but for totally unrelated reasons.
Okay, so you're not against the instrument, you're just against the...
Yeah, I'm looking for opportunities to lower the black gas limit, and this is why.
Okay. Yeah, just to point out that like while they're of course, I mean, so from a state growth point of view, of course, I don't think there should be any concerns. Well, except for maybe that the gas limit increase could be sticky, where once people come back online, maybe it's hard to bring it back down. But besides that, there really shouldn't be any concerns because it just keeps the state growth rate constant, because it only compensates for people who are offline. On the peak kind of networking constraint side, of course, that it does propose a bit of an added strain because while the average remains constant, like basically the peaks, like instead of having 1 block every 12 seconds, maybe with a couple % offline, we have like on average 1 block every 13 seconds, but it's 10% higher or something, bigger or something. So that's 10% increased peak networking strain. But it's important to point out that like after in proof of stake, we already reduced the peak network strain quite a bit because under proof of work, we had these stochastic block times. So you could have like 2, 3, 4 blocks within a couple of seconds. And now we have like this minimum of 12 seconds in between blocks. So there's already like a big reductions in peak strain. So this kind of small added increase again, when we increase the gas limit, should not be concerned under that point, viewpoint either.
Right, but it's worth noting that there's probably, so assume you go with this, like you increase the gas limit to offset the average missed slots loss, you're still in a case where like you might have an effective lower throughput if somebody goes offline in kind of an emergency fashion, right? Like, and that's kind of the case we're not solving for. So if a validator goes offline for 6 hours, you know, or sorry, a large swath of validators go offline for 6 hours, probably not enough time to coordinate raising the gas limit. So what happens, like for those 6 hours, you know, the network just has lower throughput. And that's kind of basically the price we pay by not implementing your proposal, right? Is if there's a case where a large part of validators drop for a short enough amount of time that we can't actually coordinate to raise the gas limit, that throughput is kind of lost forever.
Correct.
Correct. Yeah, and then
sorry.
Also, no, sorry, go ahead.
So we're moving from a system where blocks come in on average every 13 seconds to a system where blocks come in on average every 12 seconds. So to some extent, there was also a slight increase in capacity coming from that, which maybe offsets the fact that some blocks might be missing.
Right. If like less than 8% of blocks are missing, it's still a net increase.
Yeah, maybe just because, yeah, it sounds like right now we are really pointing towards pushing this to Shanghai, which I'm personally absolutely okay with. Maybe just there's like one last attempt though. I was just wondering, Danny, you were saying that you think by now we already so late in the process that it's probably going to be unavoidable that this would delay the merge. And I was just curious to hear like a little bit more about that, because I'm just wondering, I definitely can see that for these more involved proposals, there was this extension section. But with the base mechanism, it's, to me, it really seems like 5-6 lines of code change in the execution clients each, with, of course, plus a few added tests and everything. So I'm just curious to maybe elaborate on that a little bit.
I think the intention right now is to have a Kintsugi testnet up in the first week of December to stand up through the holidays to begin to make decisions in January about very concrete and realistic timelines. I believe if you don't put a EVM change into that testnet and then are working on testnets in January with that change, that you've very likely in practice delayed the merge because of our need to have thing on testnets, even though there are a couple line changes. I also, and correct me if I'm wrong, but the discussion and analysis that I think we'd probably want to throw behind this thing is probably still not totally done. Is everyone comfortable with where we're at? And so I'd like shoving it into Kintsugi DevNet in 2 weeks' time doesn't seem likely to me.
Okay, I mean, if that's the case, then I agree that pushing it to Shanghai is the better choice, I would say.
Yeah, does any client feel strongly that we should have this for the merge? Okay. I guess that's pretty clear then. So yeah, I also personally feel this is something that would be really valuable to have in Shanghai, and there's a lot of interesting conversations to have also about like the elasticity factor and whatnot that we might want to change for Shanghai. So yeah, but I think it makes sense to just not include this in the merge.
Okay. One last brief remark though, just because it came up and it's not really related to the AP itself, but it did come up in the discussion on Monday. And that's just because we talked a little bit about the elasticity, and one of the extra concerns that Martin had last Alcodevs was about like the slow block DOS attacks on the network and how that could make it worse. And even if we don't do this EAP now, basically, of course, slow block attacks in general are still a thing. And one thing that did come up on Monday was the fact that the impact of these kind of DOS attacks would be different after the merge than they are before the merge. And so it's just maybe something to keep in mind that this could be something worth valuable to test on a testnet. Basically, just have a testnet and just really crank up the gas limit all the way until the computation time of blocks kind of starts to go close to, say, 6 seconds or something. So we can see how a network would react under this kind of situation, because if not implemented ideally in execution clients, the impact here could be worse under proof of stake than it is in under proof of work. So just, I don't know, something that came up and might be relevant even without the CIP.
Why would it be worse under proof of stake?
So basically just maybe it's offline.
Yeah, just so we have time for light clients and Yorgos' ZIP.
Right. Yeah. So like just 15 seconds, basically, just because the nature is different. Like in proof of work, you basically just create your block and then you start like just trying to find a head to mine on top of it. Whereas in proof of stake, you have this fixed window, and so like there's more specific timing considerations where like if you miss your window, you can't just do it later or something. So yeah, it just is in the difference of the nature. And like if you implement the execution plan correctly, it shouldn't be an issue. But if there are like some non-ideal behaviors, it can be worse. But yeah, we should discuss all that.
Right. Okay. Both of them would result in many uncles, and maybe slightly different behavior, but I'm not convinced strictly.
Cool. Yeah. Let's continue this in the merge channel. Cool. Last but not least, Light Client and Yorgos have an EIP. Oh, and Alex have an EIP that bounds the historical data in execution clients. Yeah, guys, do you want to share, give some context?
Yep. Hello there. So I will do a small summary. I don't know if we have enough time to really like exhaust everything, but I'll do a small summary of the proposal as it is. So the high level thing is that we want to specify how clients can treat historical data, like, old blocks, states, receipts, and that kind of stuff. The obvious benefits is that there is a variety of use cases that don't use those data. So we can prune a lot of hard disk space with that. And also execution engines don't need to keep old EVM versions around to parse those blocks. So there are a bunch of benefits. So that's like the high level thing. And now in terms of specification, what EIP 4.4 does is that it does two main things. One is it specifies the time threshold below which you can start pruning historical data if you want so as a client. And another important thing that it does, even maybe a bit controversial, is that it specifies that clients must not serve old historical data over the P2P network. And right now, the proposal, EIP 4.4, is forcing clients to not serve such historical data because it does not want to make it optional and then have other clients rely on that optional feature, and then like the quality degrade over time as more and more clients ditch this optional thing. So that's one thing. These are the two things that the proposal does: define the time threshold and specify the networking logic. Also, this has implications on syncing. So since historical data won't be kept till infinity, clients won't be able to do full syncs and this kind of things. And the proposal basically piggybacks on the weak subjectivity system so that clients can still sync basically to a safe checkpoint. But the way this should happen is out of scope for EIP 4.4. Finally, the proposal also contains a bunch more discussion on various like miscellaneous things. So for example, various ways that such historical data can be retrieved, or how clients can sync from Genesis, or how the UX should be. But it just basically touches on them, and then it leaves it for other EIPs or other topics, basically. So that's it so far. We pushed the IEP to wherever EIPs get pushed, and we've gotten a bunch of feedback. Most of it is around the networking logic and whether we should like force clients to not serve ancient data. So whether that should be a must clause or a should clause, and also about the dev P2P responses that clients should give out when they ask for such data. So that's it for the EIP 4.4 summary. Alex or Light Client, you can say more, or we can go into the discussion.
I guess, does anybody immediately have questions or comments?
Martin had his
Yes.
hand up first.
So this looks very much like something that Peter started thinking about and presented and talked about in, I think, Prague a couple of years ago. It didn't pan out eventually. I mean, we haven't implemented it, but I'm curious, Peter, what since you considered this idea a couple of years ago, what's your thoughts on it now in this context? If you are still here.
Yes, I'm here. I have to look into it in the current context. I know that way back, we're talking about chain pruning, right?
Yes.
So way back, one of the bigger problems was that we kind of needed a way to distribute prune chains because we kind of felt that so there wasn't so currently in Ethereum 1 world, the promise is that the chain is accessible, and whether that's past headers, blocks, or even receipts are accessible, and that's kind of rely on that. And for us to just replace this guarantee with some other infrastructure, we kind of needed something that is as reliable, almost as reliable as locally having the blocks available. And I know that the best suggestions was that we could have some form of infrastructure ran by major players, kind of like EF, consensus, whatever. A lot of people, we could have bigger companies running this infrastructure, and they could just serve the past historical blocks. It's a bit wonky because it's outside of the protocol, so it's we never really were a fan of it. And the reason why we kind of dropped it is because it just requires a lot of bureaucracy, a lot of politics to dream up such a system. So it's not the challenge here is not really the technical aspect, rather it's the whole governance aspect of who is going to be part of it, why, etc., etc. And then essentially we just had better things to do. That's why we dropped it.
Do you think that with the reliance on weak subjectivity checkpoints for starting clients, that the technical issues of not having those blocks available is alleviated?
I don't really see any. The problem is not synchronization. I mean, we could have synchronized, so we could have just released hard-coded starting blocks or starting hashes in get, and just say that, well, you're going to. So this whole week subjectivity, we could have implemented that in get a long time ago. The problem is that dApps rely on past state being available, and Ethereum users are. Ethereum 1 promises to have that available. And that means everything is built on this assumption that you can always access the transactions in block 5 or the receipts on block 5. With this merge, I think that's an opportunity to go back on this promise, so to say, and just say that, well, long term, for the long term health of the network, we're going to change these invariants a bit. But
Well, and it does reduce the debate. Like, you could argue releasing checkpoints in proof of work, you're like, oh, well, that's not pure. Whereas in proof of stake, like you must have a recent piece of information to safely sync the network. And so that the need to have all historic block headers on the network to be able to find the chain ahead does become reduced because of the security model shift. That's probably not the crux of the issue.
Yeah, just because we're basically at time. Andrew, I see you have your hand up, so we can go over your thoughts and then wrap it up. I've shared the discussion link in the chat as well for like async conversations.
Right, so I'd like to notice that Aragon at the moment doesn't have snapshot sync. We rely exclusively on sync from Genesis. So this change will broke Aragon. We'll have to think of a workaround. Also, to my mind, like on some general notice, it's better to do this change closer when we have a solution on state expiry. Without, like, to my mind, it should be bound to state expiry, other than or some infrastructure for state delivering, or at least wait until all clients have their own system of reliable state delivery. I agree that like there was a promise in ETH1 that all kind of historical data is available, and we cannot break this promise without having either like proper infrastructure in place or some other mechanism, or maybe like either individual mechanism for each client or some agreed upon mechanism, but to my mind, it's premature.
Right.
To be clear, we're looking at like this happening in maybe 12 to 15 months. So this is very early in the cycle.
So just to emphasize two things. One of them is this wouldn't be implemented and rolled out now. The only thing I kind of personally feel that it's important to say is that come the merge, we should and must, if we want to ever do this, whenever, then we must at the merge explicitly state that the state older, the chain segment blocks older than X years, I don't know, will not be available as a full node. So the full nodes don't guarantee this. Now, whether we will implement this in 1 year, 2 years, 5 years, or never, that's a different story. The idea is that we need to get people to stop relying to stop expecting blocks to be forever available. And the reason, just to answer the other note that you said that this whole thing should be rolled out together with state rent or pruning or whatever, the two things are a bit separate. For one, the blocks currently outweigh the state 4-to-1 or 3-to-1 or something like that, so they are significantly heavier. But essentially, what currently one protocol improvement proposal are witnesses and stateless clients, or varying degrees stateless clients. But all these require some witnesses that need to be retained beside the blocks. And these witnesses are significant in size, so they are maybe about 1 order of magnitude larger than the blocks themselves. So as long as there is no pruning on blocks, we cannot implement witnesses because it's just going to blow up the stuff we store on this to unimaginable proportions. So essentially, all the witness work depends on an aggressive pruning strategy.
Just because we're past time, there's a comment in the chat about maybe doing a breakout session next week. I'm not sure if there's like urgency here, like given this is something we might want to do in the next year or two. If we can also just discuss it on the next All Core Devs and kind of pick up the conversation there. Yeah, so does anyone have like a strong preference for a session next week, or is like the next All Core Devs fine with people?
I have one strong suggestion. Next protocol is fine. Solving the technical aspect of this issue whenever is fine. There's absolutely no rush. But I do think it is super urgent for us to decide what guarantees we want the chain to have after the merge and start prepping people accordingly.
Right.
Sounds like we should discuss it next all core devs then.
Yeah, and I feel like the thing is, this also kind of benefits from having a lot of different people involved in the conversation, and we when we have these breakout rooms, we tend to only get a subset of people. So my hunch is like we should probably wait until the next Core Dev so that we have kind of more people, but also center the conversation around kind of the guarantees we want to provide and stop providing around the merge. And EIP 4444 is like related to that, but not the exact same thing. Does that make sense?
Yes, although I would, again, if you bring a lot of external people, I would emphasize that the discussion is not whether to prune past stuff or not prune past stuff. The discussion should be centered around how do we stop chain growth?
How do we stop what, sorry?
The unbounded growth of the
Right.
chain.
Yeah.
So that is the goal, and that essentially, if we want Ethereum to stay alive for the next 10 years, that problem needs to be solved. And just saying that, well, we'll just kick the can down the road, that won't work. So we need to stop, we need to start deleting stuff.
Right.
We can debate what to delete, but we cannot debate whether the need for deletion.
Cool. That seems like a good place to end. We're already a couple minutes over time, so appreciate the people for staying over. Yeah, thanks everyone, and I will see you 2 weeks from now.
Thanks,
you.
John.
Thanks, everyone.
Bye.
Bye. Thank you.
Bye. Have a nice weekend.